Probably the most important non-clay making day that we've had, okay? When you walk out of here, beams of light are going to be coming from your brain because you're going to understand what happens with this material right here, okay? What is this? All right, so let me just say also, it's my time. Please participate, okay? But don't talk the whole time. What is this material right here called? Clay. All right? Now, it's a little bit more advanced than that. It's a little bit more advanced, so I need you to write this down. We have Al2O3 2SiO2. These are notes, just so you know. You're writing this down. 2H2O.
Where do you write that on?
You can write on the back. Anything that I write around here will go on the front page. Anything that is outside of that, you might write it on the back. Al2O3, 2SiO2, 2H2O. We've already determined that that is what? Clay. What is the scientific term for this thing right here?
Clay.
No, for the numbers, the elements and the numbers provided.
Isn't that the number of elements that they used to make that?
Right, what's it called, putting many together?
A mixture.
Many compounds. It'd be a mixture or a formula. This is the formula for what? Clay. Okay? Simple as that. All right? Now, let's break this down. Who in here can be my genius and tell me what the last ingredient in clay is?
Water.
Yes, Kevin. Water. Write it down. Wawa.
What that?
All right?
Agua.
How many parts water do you see?
2.
2. 2H2O. Make sense? All right.
No, it's an L.
Al2O3, 2SiO2. Who can tell me what they think one or the other of those compounds are?
Sand.
What?
Si is silicon.
Silicon oxide, also known as what? Silica.
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 Thank you. Perfect. Perfect. Silica. All right. Silica is also another word for what? Silica is another word. It's like sand. If we melt it, it does glass. Write it down. Silica is glass. All right? Now, the most confusing part of the whole day is that what this is. What's Al?
Aluminum.
Aluminum. And with the oxygen or oxide, it's called alumina. You can write that down. Alumina. Okay? Alumina. This is the confusing part. Alumina is actually what?
A metal.
No. Clay. Wow.
What a guess.
Karen. That's awesome. Okay? So the stuff that we're using here is not just clay. It's what? It's clay, water, and glass. Okay? Now, this chunk of clay that I have here, right? By going like this, well, let's use the same analogy or the same example. If I take this and I squeeze it through my hands like this, what's going to happen to it? Is it going to stay or is it going to bounce back? It's going to stay. What in the clay allows me to squeeze it, for one, and it holds it in place? What allows that to happen? Yes? Water. Okay? I need you to understand that that's water. Hi. All right? So, you must have the right amount of what? To be able to make a pot. Water. Nadia. From Miss Kennedy. Okay? It's in guidance. Guidance is directly across from us. Directly across from us in that building.
Oh, that's the wall.
It's like part of the main office. All right? So, to be able to make a pot, we must have the right amount of water. This is the first stage. I'll put 1 here. stage of the cycle of clay, let's write it down, is called plastic. Plastic clay. Plastic has the right amount of water so that we can make pots, so that we can make sculptures. We can form it. We can roll it into like a snake-like form and stack it up like a coil pot. I can, because it has the right amount of water, I can put it on a potter's wheel and spin it around, squeeze my fingers, and make a nice big pot because it has the right amount of water. If I let this chunk of clay here sit out all night with nothing over top of it, no bag or anything, and let it sit out, can I come in tomorrow and start molding it? I can't, okay? So I know that plastic is a weird word. It's not plastic. Plastic is just saying pliable, wet clay. That is the type of clay that we have to have for this class, okay? All right, before I move on, let's do this. All right, everybody do this. Don't be too cool. Don't be too cool for this. What some people say, it's happy hands or something like that. I don't know.
Spirit fingers.
Spirit fingers. Ooh.
That's right.
Go team. All right. So we have two things represented, and it's surrounded by another thing. It's three parts. Not air. We are surrounded. These two spirit fingers
That's right.
are surrounded by water. So what would this represent here?
Air.
No.
Water.
One is alumina, and one is what? Glass. Okay? There's alumina, which is clay, and there's glass, and there's water all around it. That's where we are at this stage. I need you to remember this. Okay? Highly important that you understand alumina, silica, and clay. I mean water. Okay? The right amount of water is going to lead us to make pots. Okay? The next stage of the cycle of clay, do you see that we're going around in a circle, folks?
Yes.
All right? We're going to be moving this way.
Was that formed?
Formed. The next stage, number 2, is formed. What are we forming? Clay.
Clay.
What are we forming it into?
Pots.
Pots or sculptures.
Anything.
Okay? What are some ways that we can take the clay and hold our hands and squeeze them and push them and pull them? What are some techniques of making pots? What's the first one that we've already learned?
Pinch pop.
Building pots? Pinching. Pinch is one.
I got it.
Anybody know any other building methods that we'll do in here?
Wheel.
I've shown you one. What is it?
Wheel.
Wheel. Pinch. Wheel. We are forming clay into pots. Formed. Right? Anybody know any other ones? Yes. Coil. And the last one you might not be familiar with is slab.
Wow.
Okay? Slab is a sheet of clay, and we can make like house-type forms, or we can make tall cylinders out of a sheet of clay. It's called slab. You'll learn that one near the end of the class. Okay? So we're, with our mind, with the demonstration that I gave you, we are forming pots. Using our notes, getting better. Right now you guys are doing pretty awesome so far on forming pots. Okay? Now, the next stage, let's digress over here. Let's digress over here. Over here, we have 3 factors. 3 factors. Hold on. Bear with me. 3 factors that affect building. Okay? 3 factors that affect building. Write that down. When I'm working with clay, what is the air doing to the clay? Yes? It's drying it out. Okay? The first factor that affects building clay is what?
Wait a minute there.
It's drying it out. What is it?
Your hands.
No.
Air.
No, we're drying it out. It's the air. All right? Air. Air is the first factor. Okay? If our pot pots dry out too much. We can't work with them. So the air is affecting the clay. And someone said your hands are drying the clay out too. But the air is what is the biggest factor. All right? The second factor that affects us building pots, okay, the opposite of air.
Water.
Opposite of air, what is it?
Water.
Water. Number 2 is water. All right? If I have too much water on the pot and I keep spraying it and spraying it, let's say that you're building a large pot, okay, and you're keeping it in a bag to keep it wet, but you keep spraying it a little bit too much to keep it wet, at some point, physics is going to take over. And when your pot gets too wet, it starts going like this. What physics term is making it go like this? What is it?
Gravity.
Gravity. That's number 3. Okay? These are things that we have to take into consideration. Air, water, and gravity. We have to take these into consideration. All right? We'll come back to that. What are the 3 factors that affect building pots? Air, water, gravity. Okay? Now, I formed some pots. Okay? The clay was plastic. It's pretty wet. All right? When the clay starts drying out to what's called half dry, it becomes leather hard. That is the 3rd stage of the cycle of clay.
Leather hard.
Leather hard. It's a weird term. Leather hard. Half dry. Okay? Half dry. We want our pots to firm up a little bit so we can do what to them? Think about it. Think about it. What? Not exactly paint. That's going to be in glaze down here. What, how will we make designs? By doing what? Carving. Okay? At leather hard is a time that we change the pot. Okay? It's firmed up a little bit and it can hold itself up, and if I cut a section out of the pot, like this pot has a hole in it. At leather hard, it will stay together, but when it's really wet, it'll probably fall apart. Okay? So if we want to change, like carve, if we want to cut, if we want to add, what would I add to a picture? What would I add to a picture?
Color.
The handle and it's a spout. Okay? What did I do to the rim? It was like this. What did I do to the rim to make it look like that? I could open it and push it. I cut it. Okay? We do this at what stage?
3rd stage.
Leather hard. Okay? Add, subtract. Alright? Anytime that you're going to change it, we do it during leather hard. Alright? The color is important for you to understand at leather hard. So let me show you this. I kept this under bag so that you could see. I need to keep this wet and leather hard. Okay? What color is this? Is it totally white?
No.
Is it really light gray?
No.
No? What color is it? Alright? It's a dark gray, a medium gray. If I want to drink out of this, and I was going to drink, hot coffee, what would I add to this pot? A handle. Okay? I'd add a handle, so I'm not touching the pot. What stage would I do that at?
2.
Leather hard. Okay? So see the color? It's important that you know the color. Because once it gets to the next stage, you're not going to be adding a handle. You're not going to be carving into it. Okay? So what I did last period is I just took this tool, and I'll do it opposite. And it's leather hard, so the clay is firm, but it's not too firm to where it will fall apart. So all I'm doing is just changing this a little bit, and I'm bringing a little bit of emphasis to the bottom by adding a little triangle at the bottom. So I had some here, I had some here. Okay? I can do it at leather hard because the clay still moves, but it's firm. It's halfway dry. All right? Here's my cool card so that you can see it. All right? Pretty cool? All right. So, let's say that I'm done working with this pot right here. Okay, yes? I'll have to talk about it someday. I do some weird things on purpose, and it might freak you out, but I did this on purpose, and we'll have to have a conversation about it. So I can do pots that are very round and somewhat perfect, but I like to change them, and I do it at Leather Hard. Nice plug for Leather Hard, huh? Right. So, let's say I change my pots. I put my name on the bottom, I'm pretty much done with it. I take it, I put it on my shelf, like you guys have over here. What is the air doing to the pot? Drying it out. We want the pot to become totally dry for the next stage. The next stage, write it down, is called bone dry. Okay? Bone dry. Very important. Bone dry is very important to the process of the cycle of clay. You can kind of just see, where we're going with this. This is a lump of clay. These are some pots that we formed. I changed them, and these are going to be some pots that are dry. I can't really draw dry, okay? But we know that it's bone dry. All right? Bone dry stage has no what?
Moisture.
No water. All right? So here we are again. We're at here. What are these? What do I have here? Spirit fingers. What do they represent? Alumina, silica. What's all around me? Air. Okay? The water is gone, right? The water's gone. Okay? No water. Now, look at this pot. Look at this pot. Everyone, hello. This pot is different in what? Okay. Color first. All right. What color is this? All right. Is it totally white? Because look at the next stage. All right. Light gray. Write it down. Bone dry pots are light gray. They are chalky. Whoa, wrong one. Pretty much you're writing down what's in blue. Light gray. Alright? Now, bone dry is very important to understand this. Let's say you made this nice bowl. Don't look on the other corner. Okay? Let's say that you made this nice bowl right here. Alright? You go to your shelf and you want to put it in the kiln to get it fired. It's sitting on your shelf. You go up and you got to pick it up like that. All right? Did that look like I was straining to do that? What can you say about bone dry pots?
Fragile.
Fragile is the key word. All right? Write it down. Bone dry is fragile. The water makes it plastic and move around a little bit. The water's gone, so it's fragile. How many people thought that when they dry out, the clay is completely hard? Okay? A lot of people think that. It's not the truth. It's actually the opposite. Bone dry is the most fragile stage of the cycle of clay. Most fragile. Okay? Now, there's a purpose why we want our pots to be bone dry before the next stage, Ian. There's a reason why we want our pots to be completely without water before we put it in the what? The fire or the box? The box, the fire, kiln. Okay? There's a reason. So, I have my bone dry pot. You don't need to draw this, but I'm just going to show you. Students who don't think about how good they're making pots, make pots that are kind of thick. Okay? Thick bottom pots. The pot might look bone dry and light gray on the outside, but what might be on the inside because it's too thick? Water. Alright, so there might be water here. Now, we want our pots to be bone dry because when we put them in the kiln at 212 degrees Fahrenheit, what would happen to the water at 212 degrees Fahrenheit? Yes. It's not going to evaporate. If the water is there, we get to there quickly, what's going to happen at 212 degrees? Huh? Boil. The water is going to boil. It's going to create steam, and what's going to happen to the pots? It's going to explode.
No.
Yes. No, at my 7th grade class, they're like, oh, can we watch that?
That'd be so sweet.
Yeah, but I mean, their heads would probably, be on fire. That would be bad. Bad stuff. All right? So, we must have our pots, we want our pots to be bone dry when we put them in the kiln. So I haven't got this part yet, but I want you to understand it's ready to fire. Bone dry is ready to fire. Okay? Here, I need you to put a line. All right? This is a line that stops on the cycle of clay. Our pots have not been what? They have not been fired. Okay? So, if I don't, let me ask you this question. This pot right here, if I take this pot and I throw it in the ocean, what's going to happen to it?
It's gonna go be there. Freeze.
It's going to be there for how long?
Ever.
Probably forever. Okay? So, that's going to be there forever. If I take this pot or this pot that's bone dry, or this pot or this piece of clay, and I throw it in a bucket of water, what's going to happen to that clay? The clay is going to break down and it's going to become like mud again. So what does that tell you about this line? Clay can be what? Yeah, that's true. We can recycle after, anything, not after, anything before it gets fired, recycle. This is called greenware. Greenware is anything that is not what? Greenware is anything that is not what? Fired. Okay? Recycle, not fired. Okay? Greenware is any part of the cycle of clay. It's just a term that you need to understand. But the real reason that you need to understand it is that I have many students, even after I go over the cycle of clay, okay, and I explain what greenware is and what fired is, I will find a pinch pot in the recycle bucket that is Bisque fired, and it's not going anywhere. Okay, it's not going to break down. We're going to recycle some of our pots, and you'll see that they dissolve and become wet clay again. But this will not. Greenware cannot be recycled. Sounds like a test question. Can greenware be recycled? Oh, I just said the wrong thing. Greenware can be recycled. Okay? Hopefully I'm not confusing you. All right. So, we take our bone dry pots. We put them in a what? Kiln. K-I-L-N. K-I-L-N. Not kennel.
Hey, you said it.
Many times they're like, oh yeah, you put the pots in the kennel. Those would be stinky pots. Okay? We put them in a kiln. Now, here's where some of the magic starts happening. What are these?
Spirit
What are-
fingers.
Spirit fingers. What do they represent?
Magical.
Alumina and silica. I got so many people that are right on page with me. Okay? Alumina and silica. Now, I put this pot in the kiln. This is a pot. All right? 500 degrees. 800 degrees. Going up, up. 1,000 degrees. 1,200 degrees. 1,500 degrees. 1,700. 1,800. 1,850. Gabby, what temperature is this? Exactly. 1,850. 1,850. Okay? What happened to my silica and my alumina at 1,850 degrees? Gabby, what is it?
It melted together.
It started to melt together. Okay? What is between my fingers? Huh?
Air.
Air. Okay? It's not totally together yet, and you're going to understand in a second. So what I did, the term is called, the next stage of the cycle of clay, Bisque fire. Bisque. Not diss. You're dissing me right now by talking too much. Bisque. Bisque fire. All right? So what we got? 1, 2, 3, 4, 5, Bisque fire. At what temperature do we bisque fire to? Huh? 1,850 degrees. Alright, some people fire at 1,800, some people 1,900. It's around in that range. Okay? 1850. What happened with the silica and the alumina? Join. Gabe, stick with me. Joined halfway. Alright? Silica and alumina joined halfway. Alright? Now there's a reason why we only went halfway. What are we going to put on our pots after we bisque fire it? Anybody remember what the term was? Glaze. Okay? So let me jump up here. Alright? The next stage of the cycle of clay, and we're almost gone around the whole cycle of clay, is going to be glaze. Alright? There's a specific reason why we only went halfway with this fire. And there's a specific reason why we fired the pot. Okay? So, let me just add, well, we'll come back to that. Glaze is another term for what? Glaze is what, Kevin? Glass. I need you to know that. Glaze is glass. If I ask you what glaze is, you say it's glass. It's a sheet of glass that covers the pots. Okay? There are two basic reasons why we do this. Why we put a glaze on our pots. One, eat out of, what is that called? It makes it what? Edible?
I don't need
You could say
Durable.
usable, what's the F word? Fun.
Functional.
Functional. Alright? Number one, glaze puts the fun in functional. I just made that up. That's pretty awesome. Functional. Glaze makes our pots functional so we can eat out of them. But a lot of times when you choose your glazes, you're going to choose the blue glaze with the cool texture, like something like this, because you want it to sit outside or sit in your house somewhere. What would be the purpose of that glaze?
Looks cool. Looks cool.
What? Someone say? Decorative. Okay? There are two reasons why we glaze. Function and decoration. Okay? Huh? These are all functional. Mostly all the pots that we make will have functional glazes, but how you use them is going to be your choice. And we'll talk about that when we eat out of our bowls in here. Okay? So glaze is glass. And we put this glaze on our pots so that we can use them and so that they're kind of pretty. Alright? So let's go back. Glaze is glass and it's a powder. I must mix it with what? Well, it's like colored glass. I have to mix it with water. Okay? I can't just sprinkle powder onto the pot and have it stick. Okay? I can't just do that. I have to mix it with water so that I can take the pot and dunk it into the water. Gabe, help me out. You will be able to look at me, even though I'm not as good looking, but look at me. All right? I dunk the pot into the glaze that has water. Okay? That's the only way I can get a sheet of glass on my pots. All right? Why did I bisque fire it to where it's halfway? Think about it. Why bisque fire? Ian?
So it like fills them up, like the air pockets, or
What goes into the air, leaving the glaze on the outside surface? What goes into the pores of this? Huh? What? Water. Okay? Think about it. If I would have went like this with the clay, water's not getting into it. I would not be able to put a glaze on my pot. So what I do is I fire it halfway like this so that the water goes into the bisque fire pot, leaving a sheet of chalky glass. All right, this black stuff on the inside is just a sheet of chalky glass. All right, the water absorbs into the pot, it goes away, it dries out. Okay? Now, on the other hand, let me put my cards up so you guys can visually see these things. All right? On the other hand, why can I not dunk this bone dry pot into the water and glaze? Yes? Huh? Well, it has a hole, but I could still do that. Why? Let's think about in here. Yes?
Does dissolve.
The clay will dissolve. Does that make sense? I cannot glaze this because the water will attack the pot, the bone dry pot. It's like real porous, and the water just takes in and just starts dissolving. Okay? So what we do is we bisque fire our pots halfway to 1850 so we can put a glaze on it. So that's the last thing I want you to write for bisque is ready to glaze. I'm going to tell you guys right now that our test on this cycle of clay will be one and only test this 9 weeks. All the answers are all right here. Okay? Why do we glaze? Or why do we bisque fire? To prepare for the glaze. Okay? Easy enough. All right? We dunk it in the glaze. It puts a sheet of powdery glass on our pots. Okay? We let it dry out a little bit. We put it back in the what? Kiln. And we glaze fire it. Last one, I'm starting to get a little bit too much information here. The last stage of the cycle of clay is glaze fired. Anybody know what time we get out? Okay, perfect. You guys have a little time to relax. No. All right, the grand finale. I put this glaze, you can't see this, but there's a white glaze on here, on the inside. It's going to be a nice, it's actually this white glaze right here. It's going to be a nice sheet of glass on the inside. All right, so I dunked my pot in the glaze. Whatever color I choose, you're going to have a lot of colors. We make our own glazes. See all the chemicals on the back? We make our own. We mix them. Different colors, different textures. We're one of the only people that, one of the only schools that really do stuff like that in high school. So we dunk it in the glaze. It dries out. We put it back in the kiln. All right, grand finale. All right, our pots are like what right now? Show me. Show me what our pots are looking like. Okay, it's looking like this, but with glaze on the outside. Glaze is a sheet of glass. So I put it in the kiln. I slowly start going up. 200, 400, 800, 1,000, 1,500, 1,800, 1,900, 2,000, 2,100. Watch my hands. 2,200, 2,250. Okay? 2,250. What happened at 2,250? Yes, Gabby.
It melted together.
It melted what together?
The glaze.
The glass that was in the clay and the alumina melted together and it bonded like this. Let me do a sound check for you. And also for bisque fire, make sure that you write down that it's white. Hear this thud? Okay? It's together. It's not going to break like this. Alright? But it's got a thud to it. Listen to the difference of this pot. Higher or lower pitch?
Higher.
It's higher. Okay? Why is this a higher pitch?
Higher.
Show me. Show me. Okay? This is why we fire at 2,250 degrees. Okay? So that the clay bonds together, and it also helps you to contain water. But at 2,250 degrees, what happened to the glaze on the outside also?
It became shiny.
Huh? It became shiny because the glaze did what at 2,250?
Turned to glass.
It turned to glass. It melted at 2,250 degrees. So before this, it looked like just chalky stuff. Okay? So at 2,250 degrees, the glaze melted onto the pot, and then it slowly cooled down. I open up the kiln door. I grab my pot. I go get my Cheerios. Well, maybe I wash it out, maybe. But I'm hardcore. So I put it in there, and I start eating out of it. I'm good to go. All right? Our glazes aren't toxic. Like, you know, it doesn't have lead or anything in them. We can eat out of them. All right? Why do we use clay? Why do we use clay in this class? That's the basic question. Why do we use clay? Yes?
Organic.
It's organic to where we can do what with it? We can mold it, but we can fire it so we can do what with it? Use it or use it for decoration. Okay? That's it. All right? I appreciate all the people that stuck with me today. I know it's a long one, but now when you walk out of here, beams of light
I feel
will be
smarter.
shooting out. How many people feel like they're smarter today?
Oh yeah.
Okay? How many people had no idea